This is the second video in a series of videos looking at how a platform like Scratch, which is a block-based coding platform, can help us meet New York State's computer science and digital fluency standards. And we're specifically looking at computational thinking standards, and we're looking at ways that Scratch can help us meet those standards in any classroom, in any environment, responding to standards from any content. In a previous video, we looked at our first computational thinking standard related to algorithms and programming, which are standards that can be intimidating for the typical teacher who teaches their content and may not be comfortable incorporating concepts and skills from an area like this, even though there's a lot of great overlap and great opportunities to enrich their own content using this vocabulary and these concepts. So we looked at this first standard in that group, which was all about algorithms and starting just by following algorithms and recognize them as a set of steps, and then progressing into comparing algorithms and thinking about the advantages and disadvantages of different algorithms for the same task, which are just different ways of problem solving the same problem. So that's how that standard evolved from the K1 grade band all the way up to the 912 grade band. So we're going to look now at the second standard in the algorithms and programming subconcept area, which is the seventh standard in the computational thinking group. And this standard is all about variables. So you can see that we're kind of building up to the idea of variables, and they don't really get named as variables until this 7-8 grade band, where we're actually employing variables in some kind of design that we have. Before that, we really kind of build some background knowledge to help us understand what variables are and why they're important. Because in math class, variables are talked about often, but they don't always have a lot of meaning behind them for students to understand why it's important to be able to manipulate them. And a platform like Scratch can really bring the concept of variables to life in dynamic ways that students can see and get their hands on. So starting at the K1 grade band, we don't really need to touch a platform like Scratch. This is just something that can be part of a conversation, identifying terms that refer to different concrete values over time. And in the clarifying statement, we see some examples might include the weather, right? There's always weather, but it changes from day to day over time. The word of the week, today's line leader, right? These are all things that change or values that change that students see every day to help them understand that nature of changing within a concept. And then we move up to naming and labeling key pieces of information in a set of instructions. Notice that we're not specifically talking about an algorithm yet, but just a set of instructions. So if you were maybe talking about the instructions that you have to follow to get to the lunchroom, maybe a piece of information that changes in that set of instructions is, depending on the day, you might have to go a different route. So you can start to kind of build up to that idea of variables by looking at the information in sets of instructions and identifying which ones change and which ones stay the same. So again, we still haven't really touched any kind of technology here. And we really don't need to do that until we get to this 4-6 grade band, where we're still identifying information that might change, but now we're specifically looking at programs and as a program or process runs. So this is a great place to jump in on Scratch. We're looking for information that might change. And Scratch is a great place to make games, and games make excellent use of variables. One of the easiest ways to visualize that is with a score. So from the previous example, we have this project where when I press the space bar, the cat goes around and is drawing a red line in a square around this bat. If I restart it, we can see that visually happening. Now, it wouldn't be a very good game, but we could say when the cat completes this square, we earn a point, right, for our game. We can increase our score. So you can see Scratch has a whole category for variables because it's so central to what you can do in Scratch and how you can code things to be dynamic and respond in different ways to different players. So let's just take this example of a score and make it really quick so you can see how easy it is to integrate variables into this programming process. So I'm going to go down to variables, and I'm going to make a variable. I'm going to call it score. And now you'll see that score variable pop up right here. I can make it go away if I want to, but I want to be able to see our score. So I'm going to leave that there. And I'm going to revisit our algorithm or our set of instructions. Right? We set our pen color, we put our pen down, and then we do all these movements. So one thing I can do, because I know that when I get to the end of this square, I want to earn a point, which is really this last instruction, right? This is the last movement that gets us to the end of the square. So I can put something that follows that to increase that score, right? So I have these different blocks here. I'm going to use this block that says change. And notice that it says my variable, but it's a drop down, so I can change it to a variable that I already have, score. Now, when it gets to the end of this algorithm, or the end of this set of instructions, it's going to increase the score by 1. If I wanted to take a point away, I could change this to -1, but I want the score to go up. So let's test this out. I'm going to press the spacebar to run this algorithm. Move it around, and when it gets to the top, our score went up by 1. So you can see this is a value that changes. This is a variable. This number changes depending on how the player interacts with the game. This is a very simple example, but you can start to build out more sophisticated and complex ways of using that variable to make choices or different actions depending on what the player does or what the participant does. So that's a great way to just kind of visually understand why variables are so important. And that can translate to helping students better understand math problems that take advantage of variables, being able to make sense of that and have concrete ideas in their mind of why that's important. So going back to the standards and moving along, design or remix a program that uses a variable to maintain a current value of a key piece of information. So that's really what we just did. And it gets more sophisticated along the same lines in the 9-12 grade band. What I do want to point out, though, as we get to these two, we see in both of them we have the word remix, which is taking someone else's design and using it as a starting point to make some changes and kind of create your own version, which is a really important part of the programming community. And Scratch is a really great place to do that remixing as well. So if I go back to Scratch and I go to the Scratch homepage, you'll see that there's tons of projects that other people have made that I can explore. So let's just say I want to look at this cat wedge coloring game. You'll notice right away that I have this remix button because it's one of the core tenets of Scratch is to be able to collaborate as a community and remix each other's work. So this is cool because when I remix this, it basically creates a copy of this program for me, and it automatically gives credit to the original program. So if I were to share this, which wouldn't be great right now because I haven't made any changes, but if I were to share it, it would show in the notes of the project that I remixed it from the original creator. So it helps establish that remixing and building on each other's work is important. Collaborative work is important for being productive and being creative and solving problems. So that is how Scratch can help us address this particular standard in the computational thinking group of standards from New York State's Computer Science and Digital Fluency Standard Set, all about variables and how and why they're important.